So in section 1.1, we're going to cover a little bit of terminology here at first. So the first definition is really what this unit is all about. It's what is a set of values. I'm not going to write the definitions down because you have access to them in your textbook. But a set of values is basically just a bunch of numbers that are grouped together. Okay? So here's an example. So set A could be the numbers 0, 1, 2, 3, 4, and 5. Or set B could be the numbers 0, 2, and 4. Okay? So these are both called sets. So this would be called set A. This would be called set B. Okay? An element is really just a number that's inside of a set. So if I look at set A here, then 0 is an element of A. 1 is an element of A. 2 is an element of A, etc. 0 is an element of B. 2 is an element of B. And 4 is an element of B in this set here. So each of these guys in here are called elements of the set. Okay? Alright. So universal set. That's really just all the numbers that you're considering in a specific situation. So if I'm considering, say, the numbers 1 to 10 only, alright, so this would be the universal set, would be called the numbers from 1 to 10. So the elements in the universal set would be these guys here. So this is if I was only considering the numbers 1 to 10 and I didn't care about any number besides 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So it's like its own little world where these are the only numbers that exist. No other numbers exist. Okay? So a subset. A subset really is just when one set completely falls inside of another set. If I look at sets A and B up here, if I look at set B specifically, I see that B has the element 0, well so does A. B has the element 2, so does A. And B has the element 4, and so does A. So I can see that every element that's inside of B is also inside of A. That means B is a subset of A. Okay? So I can write that using the subset symbol. So B is a subset of A. Okay? It's kind of like a sideways U. Okay? Alright. Sometimes you might also see, say, this symbol here. So it's the subset symbol with a little line through it like that. That just means isn't a subset. Okay? So an example would be, let's say I have set D here that has the numbers 1, 3, 5, and 7. Okay? I can see that 1 is in A, 3 is in A, 5 is in A, but 7 is in D but not A, right? So because D has this element that A doesn't have, then I would say that D is not a subset of A. Okay? Complement. So a complement essentially means what's not in. Okay? So let's say I'm considering this universal set right here. Okay? And I'm going to take set E to represent my even numbers in this world where only these numbers exist. Well, set E, of course, would consist of the numbers 2, 4, 6, 8, and 10, right? Okay? So you notice that all of these numbers are inside of U, but there are some left over, right? 1 is inside of U, but not in E. 3 is inside of U, but not in E, right? Okay? So what I can say is if set E is the set of numbers 2, 4, 6, 8, 10, then the complement of E, which is written a few different ways, it could be written as E with a little dash sign there, or sometimes it may also be written as E with a little C. Okay? Whichever notation you use is fine. So in this case, it's what's not in E. That's really all this complement notation means. So if E has 2, 4, 6, 8, and 10, what does the universal set have that E doesn't? Well, 1, 3, 5, 7, and 9. So the complement of E is another set of numbers. It would have 1, 3, 5, 7, and 9. Okay? Alright, the empty set. An empty set is basically a set with no values in it. So a common example would be the set of odd numbers that is divisible by 2, right? So odds that are divisible by 2. Well, by definition, really, an odd number is cannot be divisible by 2, right? So when it comes to odd numbers that are also divisible by 2, you'll never find one no matter how far you go. So we say that this set here is called an empty set. So it can be written a few different ways. It could be written as the set notation, the squiggly brackets with no elements written inside it, or it could be just written as like this O with a little cross through it. Okay? So these both mean the empty set. Alright, disjoint. So disjoint means two sets that have absolutely nothing in common. So no elements are in both A and B. So no elements are in both sets at the same time. So an example of this is pretty easy. How about if I take set A that just has the numbers 1, 2, 3, and then set B has the numbers 4, 5, 6. I see that there are no numbers that are in A and also in B, quite simply. So I would say that A and B are disjoint sets because they have no elements in common. Okay? One other thing I wanted to mention before we move on is the little notation. It's another notation thing, I guess. So, and the notation you'll see throughout the unit, it kind of looks like this. Alright? So N and in brackets A. All that means in English is the number of elements that are in set A. Okay? So if I go back to my set A, that's right here. So 0, 1, 2, 3, 4, 5. So A is a set 0, 1, 2, 3, 4, 5. Well, how many elements are in here? The number of elements in set A would be 1, 2, 3, 4, 5, 6. Number of elements in A is actually 6. Okay? That make a bit of sense to you? And likewise, if you look at something like this one right here, I could say that the number of elements that are in E would be 1, 2, 3, 4, 5, 5. Or even this one here, the number of elements that are in the complement of E, so E complement, would be 1, 2, 3, 4, 5 again. Okay? So anytime you see this notation, don't get scared by it. It's just the number of elements that are in whatever this set right here is. Okay?